Okay, let's do a hard kinematics problem. How long will an arrow be in flight if it is shot at an angle of 25 degrees and hits a target 50 meters away at the same elevation? So, first thing with all kinematics problem is we're going to draw a diagram. So, it's going to travel in a parabolic path. And with all parabola problems, it's useful to just look at half of the problem. If the full distance is 50 meters, then half distance is just going to be 25 meters. And of course, we have our starting angle of 25 degrees. Next step, as with all kinematics problems, is to find the unknowns and the givens. So we're going to have a speed vector. They've given us in polar form. So magnitude is unknown, but angle is 25 degrees. And once again, with all kinematics problems, when they give you something in polar form, the first thing you should do is turn it into rectangular form. And we're going to do that right here. So this is going to be cos 25m and sine 25m. Other information we have the distance vector. Horizontal distance is 25 meters, not 50 meters, because we saw in the diagram that we're only looking at half of the problem. So this is going to be 25 meters. And our y distance is unknown, so we'll just call that dy. Last thing, they didn't really give it to us, but we know that's the acceleration vector. And acceleration vector for x is going to be 0, and for y it's going to be negative 9.81. Now that we've done our givens and unknowns, the next step is to do our formulas. Now, this problem is kind of hard, and it's hard to tell what formulas to use at first. But in physics, there's only 4 formulas in kinematics anyways, so we're just going to write all 4 of them. So you're going to have V equals d over t, A equals V over t, D equals 1/2 AT squared, and then V squared equals 2AD. Now the hardest part here is finding out which formulas we're going to use. One thing that stands out to me is that for the x component, the only formula that makes sense is formula number 1 over here. Why? Because we know that the acceleration for the x component is 0. So therefore, and all the 3 other formulas have acceleration in them. So those are basically useless to us. So let's take equation 1 and plug in the values for our x components. So our x velocity is going to be cos 25 times m equals 25 meters over time, which is unknown. So that's going to be our equation for our x component. What about y component? You have a bunch of choices here. Most of them are valid. Basically, all of them are valid, but we're just going to choose this one here because it's easier and it's valid. So if we plug in our numbers here, we have acceleration equals negative 9.81 equals change in velocity. We're starting at very high velocity, and once at the end point, the vertical velocity is 0. So it's minus sine 25 times magnitude over time. So we got 2 equations here, and in fact what we have right now is a system of equations. We have 2 equations and 2 variables, and it should be possible to solve this system of equation as long as nothing cancels out too badly. So what we're going to do is Now, obviously, there's a couple ways to do this, but what I'm going to do is I'm just going to isolate for m. So for this equation over here, m is equal to 25 over t times cos 25. And for this equation here, m is equal to negative 9.81 times t divided by negative sine 25. And we got two m's here. We can put them on two sides of the equation. So we're going to combine these two equations. When combined, we have 25 over t times cos 25 equals negative 9.81 times t over negative sine 25. And to go on from here, we're going to move this t to the other side. And then we're going to have 25 over cos 25 equals, the negatives on over here cancel out, so it's going to be 9.81 over sine 25 times t squared. And then finally, t squared is just going to be equal to 25 over cos 25, big fraction, over 9.81 over sine 25. I'm not even going to bother simplifying the fraction, just jam it into your calculator. You probably have scientific calculators or graphing calculators anyways. And if you evaluate this entire thing, t squared should be equal to 1.188. And if you take the square root of that, you will get 1.09 seconds. Now that's only for half the time, right? So the full time is just going to be double of that. And that's just going to be 2.18 seconds.